Now let's have a look at this theorem. So here it says for a given power series, now remember this is the power series notation, there are only three possibilities. One is the series converges only when x is equal to a, right? So an example of that nature is this one. So we observed that this series has when we take the limit of this ratio, it will give you infinity. So from the ratio test we have for all x values except x equals 0, this is greater than 1, so the series converges, right? And for 0, sorry, the series diverges for all the x values which are not equal to 0, and at 0 the series converges. And remember I mentioned for any power series it converges at the center point, right? So this theorem says that for any power series it will definitely have one out of these three possibilities, right? So the first example goes with the first statement. This is an example for this possibility, right? So it converges only at the center point, and the center point in this case is 0, right? So there can be some other power series with a different center point, and that will converge only at the given center point, right? When you are doing some more examples, you will get familiar with this idea more, right? And the second possibility is the series converges for all x, right? Now that goes with the third example. This one we did not discuss in a video, but still if you compute the an plus 1 divided by anth term, and if you get the limit, you can see that the limit is 0 irrespective of the value of x. So that means no matter what x we use, you will still get, like, even if it is negative or positive or 0 or whatever, you will get 0 as the limit, as the answer of this limit. So since this is less than 1, from the ratio test you can say that for any value of x, this series will converge. Now let's say, for example, if we have 153 for x, let's have it as negative. So the series will be negative 1n minus 153 to the power 2n divided by 2n n factorial, and at once n factorial squared, and at once you can say that this series converges, because the reason is no matter what value of x we choose, the limit of the ratio test will be equal to 0. So as a conclusion from the ratio test, we can say that the series will converge. And keep in mind that just by having a variable here, we cannot say anything about the convergence. Okay, to mention the convergence, you must have a number instead of x. It's like very much similar to like mentioning the odd or even nature of a integer, right? So let's say if we have 2, we can say it is even. If we have 3, we can say it is odd. But if we have x, can we say anything about the odd or even nature of this one? No, right? So you should have a number instead of this variable in order to categorize it under odd or even. So the same scenario is there for the convergence of a series as well, right? You must have a number to discuss the convergence. Just by keeping it as a variable, we cannot say anything about the convergence. So here it says whatever the number you use, you will have 0 as the limit. So whatever the number we use, the series will converge. And in the first case, whatever the number we use, if it is not equal to 0, then the limit will be equal to infinity. So for any number except 0, the series will diverge, right? And at 0, if you use 0 as the number, then you will get a finite answer and it will be a converging series, right? And here also, if you substitute the center point, then again it is 0, but not only for the center point, for any value in the real axis, it will converge, right? And the third category is, there is a positive number r. So when you say r, it cannot be infinity, okay? I mean a number, it cannot be infinity, okay? So when you say a positive number, it's just a finite number, right? Remember, infinity is not a number, right? This is just a symbolic representation. Okay, so the third category is, there is a positive number such that the series converges if this term is less than this number and it diverges outside the region. And an example for this third category is this second example, right? So here from the ratio test, we saw that the limit was equal to this term, right? So from the ratio test, we even discussed this in the previous video. We saw that if this is less than 1, right? If this is less than 1, then that means if the x values are in this region, the series converged. And if it is outside the region, that is, if it is greater than 1, then the series diverged. And also we manually calculated the convergence or the divergence for these two endpoints, right? So here it says, we know for sure that, like in this third category, we know for sure that there is a certain number. Now in this case, that number is equal to 1, so that if this term, x minus a term, and in this case it is x minus 3 term, right? If that term is less than this number, right? That is, if x minus 3 is less than 1, that is in this region, we already proved that the series converges for those numbers. And also we proved that if it is outside that region, that means this one or this one, if we choose x from one out of these two regions, we saw that the series diverges. Okay, so this does not say anything about the two endpoints, okay? Those two endpoints we have to calculate it manually. But the main idea here is to emphasize that there is a certain number r, so that if this term is less than that number, then it converges, and if this is greater than that number, then it diverges. Okay. Also, now a good way to visualize this inequality is just draw the number line and mark this center point, and this means the modulus, the distance between x and a is r. So just draw a a distance of r units and mark these 2 points. So this will be a minus r and this will be a plus r. Okay, so if the distance is less than r, then the x values will fall inside, and if it is greater than r, it will fall outside the region. And remember, this does not say anything about the endpoints. Okay, we have to calculate it manually. And this number is called the radius of convergence. Okay, this is the meaning of the radius of convergence, right? So that is the interval length or the interval radius, so that the values converge inside the interval and the series diverges outside that interval. So this radius, the meaning of radius is very important, and it has lot of applications in the analysis, I mean in mathematics, right? So, and also there is something more that I should add, right? Now here we saw that the radius is equal to 1, and it is not like, it's not, I mean it can take different values depending on the way they have given the series, right? When you are doing calculations, you will see that you can take so many different values for the radius of convergence. And here in the first example, we saw that the series diverged for all the values except 0, right? So it's like if we try to implement this idea of the radius in here, so if we have a certain radius, then it should definitely have some numbers inside that interval, so that for all these numbers the series should converge. But here we already proved that it does not have any other number other than 0. So here what we can say is the radius is equal to 0, right? So in that case, with this same sense of the interval length, you can say that it has a 0 radius. In other words, it only converges at the center point. And remember, all power series will converge at the center point, because you will get only the C0 term, right, when you substitute the center point. So here the radius is 0. And how about the last one? Here we saw that since the limit is equal to 0, for all the x values the series converges. But if we try to implement this idea of the radius here, and if we mark now here the center point is 0, and if we mark a finite distance r, right, then it says outside the region the series should diverge, right? But here we saw that for all the x values series should converge. So in other words, if we need to implement this idea of the radius, we can say that the radius is infinity in this case, right? Now see, in the first example we had a radius 0, right? Our radius is equal to 0. And in the second example we have the radius 1, and in the third example we have the radius infinity. So basically this radius means the interval length, interval radius, actually interval length means this one, interval radius means this one. So this term radius is obtained directly from the basic meaning of the radius that goes with the circle. Okay, so this is the radius and this is the diameter, right? So radius means the length from the center to the circumference. So you have the same idea here as well, right? So here we have, now we saw, as a summary, we saw that for any given power series, there is a thing called radius of convergence. So if we choose that length, and this radius, this number can be 0, or it can be a finite value, or it can even be infinity. And the method that we are going to use this radius is, if we choose the center point and if we measure this distance, if it is 0, you cannot have any distance, then it is just the center point. If it is a finite number, you should measure it to both sides, and if it is infinity, you will get the full real number set. So within this interval, if you choose x values, then that particular series will converge, and outside that region it will diverge, right? So in the next videos we will see how we are going to calculate this radius of convergence.